Hi, hello everyone. Today we are going to see about multi-stage decision making in fuzzy set theory. So the multi-stage decision making, we cannot make a decision in a single stage. So multi-stage are required for achievement. So the multi-stage decision making is a sort of dynamic process. Dynamic process is nothing but it changes according to time. So it is a sort of dynamic process. A goal is not achieved by solving a single decision problem, by solving a sequence of decision making problem. In individual stage, the sequence of the problem is one, but the multi-stage problem it can be divided into several stages. For getting the answers, we have to solve all the sequences of that particular problem. So it is not so we cannot achieve our goal in a single decision, but by solving a sequence of many problems we achieve our goal. So decision making problems which represent stages in overall multi-stage decision making are dependent on one another in a dynamic sense, which means the dynamic process is like a relay race. It will depend on the output of the first stages taken as an input of the second stage. So it is dependent on one another in changes with the time. So the decision making problems which represent stages in overall is referred as a multi-stage decision. So it is basically dependent on any task oriented control. For example, basically multi-stage decision making for we are for example, if we need a computer, we need to know about we need to have a lot of stages of our decision. So about the features, about the quality, about the working time. So there are multi-stage requirement. So to get one computer. Likewise, for any decision making, the multi-stage process is required to get our solution or to attain our goal. So, in general, theories of multi-stage decision making may be viewed as a part of a general dynamic systems. So, basically, a dynamic system referred as the it changes according with time. So, the particularly multi-stage decision making is referred as a part of general dynamic systems. The most important theory of multi-stage decision making, which is that is closely connected. Both multi-stage decision making and dynamic process are referred as same, but in particularly they are closely connected in dynamic programming because they are changes according to the time. And as the mathematical theory, the dynamic programming can be fuzzified. So in mathematical theory, whatever the dynamic program, we can be fuzzified. The fuzzification of dynamic programming extends its practical utility since allows a decision makers to express their goals, constraints, decisions, so on approximate fuzzy terms whenever desirable. So the dynamic the while fuzzification, which means the fuzzified version of the dynamic programming, it extends it express or it uses many practically, and it allows the decision makers to express their what are the requirements, such as what are the output means goals, and what are the decisions, and what are the implementation, likewise constraints that are utilized in the dynamic sense in an approximate terms or approximate way, represented in a fuzzy terms. What are the needed, what we are desirable, that are expressed in their dynamic problem to express their goals, constraints, etc. So the dynamic programming was first formulated in classical paper is Bellman and Zedek in 1970. These two people only get the fuzzy set into our sets. So the concept of fuzzy finite state fuzzy automations are used in this. To see the connection between two sections, we need to know about the decision problem conceived in terms of fuzzy dynamic programming is viewed as the decision problem regarding a fuzzy finite state automation. While we are solving the fuzzy dynamic programming of decision problem, which means decision problems which is in the fuzzy terms of fuzzy dynamic programming is solved by using a finite fuzzy state automation. So the automaton involved is a special version of the general dynamic automation. So what are the automation we used, that is referred as a general term of fuzzy automation. One restriction of the automation in dynamic programming is the state transition relation in CRISP, and hence characterized by the usual state transition function of the classical automata. So one of the restriction of the dynamic program is a state transition relation in CRISP. So what we are characterize the state transition function in the classical automata. Otherwise, the automation operates with the fuzzy input systems and the fuzzy internal states, that is to be fuzzy in the sense, which means in classical automata we it uses only the crisp internal function and crisp internal outputs. And when we use the fuzzy terms in the crisp automata, it it cannot produce the desired results. So here state transition relation referred as the behavior, that means mathematical representation of the dynamic system behavior describes that how the system state changes over a time. So that is the state transition relation, which means another restriction has no special output is needed because the internal state is also utilized as the output, and consequently two need not to be the both internal state and the output cannot be distinguished, because when our last output, that is previous output, is taken as a input of the next stage. So that why they are need not to be distinguished. Under the mentioned restrictions, the automation script A involved in the fuzzy dynamic programming is defined as a triple format, that is A equal to XZF. Here, automation used to refer the model of uncertainty in complex systems that are driven by the fuzzy logic, that are written in a fuzzy logic. This is used to define the uncertainty because it changes over time, so we need to be predict what are the desired results. Here x and z referred as a input states and z is referred as a output states of script A, and our state transition function is defined as which means the describes the behavior of the system state changes over a time, that is defined as function of z cross x to z of A, which means define the n for each discrete time t belongs to n, and the next internal state is t plus 1. The automation in terms of present internal state is a t in the present input state xt, which means nothing but z of t plus 1 equal to f of zt and xt. Xt is nothing but the input state, and zt is nothing but internal state, and zt plus 1 is known as the our desired output. So which means z of t is in the function of z naught or t naught, which means t minus 1 or t minus 1. If we have the first output is known as zt, so the next output z of t plus 1 if we need means we need to put input as the which means the internal state, that is previous output, and the input state, that is xt. So previous output and the present input are needed to get the present output. So zt plus 1 requires f of zt and xt. This type of automations are used in the classical dynamic programming. So classical dynamic programming uses this, which means the difference between the crisp automation and fuzzified automation. Here xt is the input and stored, and it goes to the internal storage, and we by internal state of first internal state is zt. The both combined version of xt and zt produces zt plus 1. This is known as crisp automation. Likewise at and ct, which is input state, and this is internal stage of crisp, which means fuzzy state, and we get output as t plus 1. In for the difference between crisp automation and falsified automation is nothing but this crisp automation says that the set is having yes or no answers only, but the falsified automations they give the detailed explanation of that particular problem, because If we get the answer, if we get the answer 1 or 0 means this is crisp. If we get some approximate value related to that means, which means 0. 0.5, 0. 0.2 up to 0 to 1, the Fuzzified set is under the 0 to 1. We get the membership values of all the decisions. So the Fuzzified version is more useful than the crisp. So the fuzzy dynamic programming must be fuzzified by using the extension principle. The crisp, we already know that the crisp function we are used. The crisp function can be fuzzified by using the extension principle. Here, the AT and CT denote the input state and the fuzzy, which means they are crisp input stage and internal stage, and the AT and CT are referred as fuzzy input state and fuzzy internal stage with respect to the time t. And CT plus 1 denotes the fuzzy internal state at the time of t plus 1. Here AT is on the fuzzy set x and CT is on the fuzzy set of z's. These are the these are the notations we are used for solving the multi-stage decision making. Hope you all understand, and thank you.